Hi, how you doing? So my name is Charlene Schwartzman, aka C Schwa. And the cool thing is that if you look in front of me, I got a couple of shapes up here. And like one of the things that for some reason we don't all embrace is fractions. And I think fractions are fun and I think they get a bad rap. So what I'd like to do today and begin with this is kind of show you little ways to kind of embrace and look at fractions and see how cool and funky they actually can be. And I'm going to pause and continue and pause and continue and just have a little bit of fun. So I hope you guys are going to join me and play along. And what I'd like you to do is hit pause for some of these things. So what you notice in front of me is I have these shapes. So if you want to hit pause and kind of draw these yourself somewhere and go get yourself some colored pencils or whatever and then come back, that'd be great. Okay? So the first thing is I am going to change my color to this beautiful pink color. So in front of me, I have a rectangle. And let's say that, this is a piece of chocolate, some delicious chocolate, and I want to split it with my friend. How many ways can I split this chocolate in half? I'd like you to press pause at this time and go find out, and I'll meet you back here. Okay, so if you press pause and you came back, I hope you realize that right here is one way to do it. Did you think of another way? And I hope so, because if you go across this way, you make a straight line, which I did not, then you and your friend can have your piece of chocolate going long ways, or you can have your piece of chocolate looking like the two little blocks. So to me, I'm seeing a Kit Kat, and here I'm seeing what am I seeing here? I don't know, but I'll let you guys think about that. So anyway, moving along here, these are called parallelograms. So what I'd like you to do is think about how you can chop these in half to actually see if you can get two equal pieces. So to me, I'm going to go along here, or I can go along there. And the nice thing is that if I flip this over and rotate it around, I get two beautiful triangular shapes. If you go to the circle, there's, oh my gosh, I can't imagine how many different ways. Imagine you're a person, you ever watch them make pizza? Pizza's delicious. So you can cut it that way and cut it that way. Now, here's my pretty little triangle. So I think I would cut it down that way. How would you cut this one so that way you would get two equal pieces? These are beautiful because you know what these are? These are called hexagons, and I love hexagons, and I can chop that sucker in half there. I can cut it across here. Now, by the way, if I pick another color, check it out. If I go from here to here, I hope you guys said, what if you went from there to there? Because then that side would be the same as that side, which I think is pretty cool. So I will be right back. What's really cool is that if you look at each one of these represents a half. So this is a half, right? This is a half, this is a half, this is a half, this is a half. So what's really cool is what I want you to do is actually go around your house and look at things and think about how you can cut them in so that way they're equal to two equal parts. You take a whole thing and you cut it in half. Like for example, like if you look at a lamp, is there a way you could cut a lamp in half? Can you cut a coffee mug down the middle somewhere? Because when you're cutting things in half, because this is half, right? This is half, this is half. This is half of this. So the cool thing is it's 1 out of 2. So half and a half gives me a whole, right? So if I have half of something and you have the other half together, we have the whole, which is pretty cool. But things are going to get more complicated than that. That life always gets a little more interesting. So that's exactly what we're going to do. We're going to kind of move on. Okay, I'll be right back. So up here, you'll notice I have 6 blocks, right? It's pretty interesting. I have these 6 beautiful blocks. I'm going to change my color right now. It's orange. I think I'm going to change it to black. Okay, so before we said you could take something and then you could cut it in half, right? So that's 1/2 and that's 1/2. And if I shade this in, this literally takes up half of that rectangle, half the space, right? Okay, so what if I had something where I was like, well, we have 1/2. I know what 1/2 is, but somebody says, well, what about 2/4? Okay, so instead of cutting my rectangle in half, I'm going to cut it into 4 equal pieces, okay? So these 3 pieces are technically 4, it's these 4, these 3 lines create 4 pieces. So this represents, so that's 1/4, that's another fourth, another fourth, and another fourth. So each one of these represents 1 out of 4 pieces. So what if I said to you, I want 2 out of 4 pieces? Well, 2 out of 4 pieces takes up this amount of space. Now, if you compare this little pink spot here and that spot over there, what can you tell me? Hit pause and think about that for a second. And you're probably saying to yourself, gee, they look like they're the same amount, okay? Then what if you had somebody coming along and they said, well, 3/6. So if I have 3/6, that means I want to take each one of these and break it down into 6 pieces. So I have to make it 6 equal pieces. 1, 2, 3, 4, 5. So technically I have 6 pieces. So just imagine over here there was only 2 of us who wanted some chocolate, but then 4 friends came to the party. Like there were 4 of us at the party. So now we have to split this chocolate between 4 people. Uh-oh, now the party's gotten even bigger, and now we have to break this chocolate into 6 pieces. Okay, so if we broke it down into 6 pieces, then you should be saying to yourself, well, this would be 1/6, that would be 1/6, that would be 1/6, 1/6, and 1/6. So each person gets 1/6 of the chocolate because there's 6 of us at the party and we got to share. So if I said to you, let's shade in then 3 out of 6, it would be, here's one of them, here's your second one, and here's your third one. So if you were to compare the orange, the purple, and the black, what would you say about all of them? And I hope you're saying to yourself, well, they're all the same. So therefore, I can put a big fat equal sign right over here. Now, these are what we call equivalent fractions because they mean the same thing. 1 out of 2, 2 out of 4, 3 out of 6. They all pretty much take up the same amount of space, which brings it down to a half. So I'm going to get crazy now. So I'm going to ask you guys, if you look at number patterns, because I'm a fan of the number patterns, I think number patterns are awesome. So if I said to you, let's look across up top, I have 1, 2, 3, and then down here I have 2, 4, and 6. What do you think could be the next fraction in our little sequence here? I hope you said 4/8. I hope you did. So these are all saying the same thing. So now I'm going to go up here. I'm going to be crazy. I'm going to get nuts. I'm going to break this down into 8 pieces. I got 1, 2, 3, 5, 6, 7. That's not bad, right? Because here's the thing. So now if you look at this, I need 7 lines to create 8 pieces. So over here I have 1, 2, 3, 4, 5, 6, 7, 8. How many people came to the party? That's right, 8 people came. So that means each one of these represents an eighth, right? Each one of these represents an eighth, an eighth, an eighth, and an eighth. Eighth, eighth, eighth. Okay, so if we were to shade in 4 out of 8, so I got a pretty little yellow here. So 4, here's your first one, here's your second one, your third one, and your fourth one. Shazam, oh my goodness, that's still taking up a half of the chocolate, right? So here's what I want you to do. I want you to take your own little rectangles here, and I want you to go ahead and turn those into what we call an equivalent fraction. So we know if I said to you, let's predict the next one, why don't you tell me what the next one would be? And I hope you're saying to yourself, well, it could be 5/10. Now, I want you to get really crazy. And if you think about it, right, look at each one of these numbers. This number is how much of that number? It's half of it. 2 is how much of 4? It's half of it. 3 is how much of 6? It's half of that, right? 4 is half of 8, because if I said what's 8 divided by 2, I hope you say it's 4, right? So then if I said to you, I'm going to get nuts, I'm going to get crazy. What if I made this 18? Could you tell me what would be, what over 18 is the same thing as 1/2, right? And you're asking yourself, how would I determine that? So in other words, if I take 18 and I divide it in half, what do I get? And I hope you're saying to yourself, well, it'd be 9. So in other words, this number is how many people are showing up to the party, and then we want to make sure everybody gets half as 9/18. Okay? Okay. So naturally, I would think that this would not limit ourselves to just, taking rectangles, because think about it, right? Think about how, what am I doing here? We're stuck. Hold on. Clickety click. Here we go. So we have ourselves some, come on, we got to annotate here. Did my mouse die already? My mouse died? Are you kidding? Let me just check here. Nope, you should be working. Okay. Oh, here we go. Okay. All right, so of course we have ourselves circles, because why would we limit ourselves to rectangles, right? I mean, there's so many beautiful shapes in the world. Why would we want to continue to limit ourselves? Now, let's say, like, when you think of a circle and mostly food, what do you think of? I think of pizza. I think of cupcakes. I think of, like ice cream cake. Oh my God, how much do you love ice cream cake, right? And so, to me, when you see somebody cut a cake up that's round, where do they seem to start? And if you think about it, they start right in the middle, right? And so that's where the center is. And then they want to go ahead and they want to say to themselves, okay, if I cut it in half, and you watch the pizza cutter. When you watch the pizza guy, you ever watch them when they take the pies out of the oven and they take it and they're like, shoom, shoom. They cut in all these opposite directions. They're like, choom, choom, choom. Because typically a pizza pie comes in, I hope you recognize that pizza pie typically comes in 8 parts, right? So what I'm going to do right now is I'm going to make this so much, how come it didn't do what I wanted it to do? I would typically think that it would. So if you take that, and come on, and I go with a line, oh, you guys not working, who cares? Okay, to like that, right? When you look at a pizza pie, right? That is typically a pizza pie is broken down into 8 slices. So there's 8 slices per pie. So now if I said to you how many slices represents half the pie, like if somebody's that hungry, have you ever been able to eat half the pie? So if you ate half the pie, how many slices would you eat? So if I'm looking at this, I'm going to shade this in orange, right? Over here, we know that all of this is typically, this would be half the circle. And if you look in there, there are 4 slices, right? 4 slices equals half the pie. Yummy, 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 yummy. Oh my God, the orange is making me think of pumpkin pie because, like, literally, it was just Thanksgiving and it was so good. But anyway, um, sometimes when parents have parties, right, they don't break the slices down into 8 slices because sometimes they're too big when kids are really little. So then they ask the guy, can you cut it down into like tenths or something like that? So now these people have to figure out how to cut the pie into like tenths or something like that. So all right, so here, let's see how you would do that. So here's what I want you to do. How would you break it down into 10 slices? How would you start? So I want you to do is I want you to hit pause and figure out how to break this down into 10 slices. Okay, and I'll meet you back here. Did you hit pause and try it? Because I'm going to show you what I'm going to do. The first thing I would do is I would cut this into a half, right? Now, typically, if it was like 4, when you do 4 slices, I'm going to do it up here. When you do 4 slices, it's so much easier because you could be like, okay, I could go like that, and I could go like that, and I could go like that, and I get 4 slices. That's great. But if you want 5 slices, you can't exactly go down the middle. You can't cut this in half and half. You want to just go ahead and ask yourself, how do I get this into 5 equal slices, right? And so, let's eyeball it. 1, 2, 3, and then 5 right there. It's so crooked, but it's okay. I guess somebody got a demented looking slice. And if you look over here, there are 1, 2, 3, 4, 5 slices. So that's still 5 out of 10, and you guys recognize that it's still half the pie. So that's pretty awesome. I do want to say that I just love the idea of understanding what equivalent fractions are. So we're going to get more into what equivalent fractions are and ask yourself, like when I said 1/2 was equal to 5/10, right? Then what I want you to think about is, to go from 1 to 5, what did I have to multiply by? And to go from 2 to 10, what did I have to multiply by? And what I hope you recognize is 1 times 5 is equal to 5, right? And 2 times 5 is equal to 10. What I want to ask you is, what is 5 divided by 5? It's 1, right? Because anything divided by itself is 1. So, and think about that. If you take any number and multiply it by 1, does it ever change? Like if I do 2 times 1, it's going to be 2. If I do 3 times 1, it's going to be 3. If I do 100 times 1, it's going to be 100. We call that, this guy right here, we call him the multiplicative, try that word, say it with me, multiplicative identity. That means that anything if I multiply anything by 1, it never changes, right? So if I were to come up here and I were to be crazy and I said 3/4, okay, equals, let's say I want to make an equivalent fraction to that, and I'm going to go to 28, okay? So here's what I want to ask you. What did I multiply 4 by to get to get 28? I just gave you the answer. What did I multiply 4 by to get 28? And I hope you said by 7, because 28 divided by 4 is 7. Now, if I want to make my fraction equivalent, that means then I would also have to multiply the top by how much? And if you said 7, you are a rock star